Functional irreducible complexity cannot arise by random chance. Irreducible complexity, IC, popularized by biochemist Michael Behe, refers to systems that consist of multiple, interdependent components where the removal of any one component would cause the system to cease functioning. These systems are not merely complex but possess an arrangement in which every part is essential to the overall function. Examples often cited include molecular structures like the bacterial flagellum, which depends on numerous proteins to operate as a microscopic motor, or the blood clotting cascade, where the absence of one component would prevent clotting altogether. The argument against the claim that irreducible complexity can arise by random chance centers on the improbability of such systems coming into existence through undirected, naturalistic processes, such as Darwinian evolution. In this article, we will explore why functional irreducible complexity is not a product of random chance but instead suggests an intentional design. Understanding irreducible complexity. Irreducible complexity refers to systems with multiple interdependent components. Each component plays a crucial role in the function of the system, and the removal of even one component renders the entire system non-functional. Importantly, these systems cannot be simplified without losing their core function. This distinguishes them from merely complex systems, which might still function, albeit less efficiently, when components are removed. Behe's illustration of the bacterial flagellum is a classic example. This molecular machine operates like a motor, with a propeller-like tail, a rotor, and other essential parts that are all necessary for bacterial motility. According to the irreducible complexity argument, all the parts must be present and properly aligned from the beginning for the system to function. If even one part is missing, the flagellum cannot work, and the bacterium would lose its ability to move. This scenario, Behe argues, cannot arise gradually through evolutionary mechanisms since partial or non-functional versions of the system would confer no survival advantage, and natural selection would not preserve them. Random chance and the improbability problem. The idea that irreducibly complex systems could arise by random chance faces insurmountable probabilistic hurdles. Let's consider this in the context of molecular biology. Proteins, which are essential building blocks in biological systems, are made up of sequences of amino acids. The average protein consists of around 300 amino acids, and there are 20 different types of amino acids. This means that the number of possible combinations for a single protein is 20 to the power of 300, which is an astronomically large number. Now, the chance of randomly assembling a functional protein that is necessary for an irreducibly complex system is not just small, it is effectively zero. And for systems that require multiple proteins, each interdependent on the others for functionality, the probabilities multiply exponentially. Evolutionary mechanisms like natural selection and mutation are often invoked to explain the gradual assembly of such systems. However, natural selection only preserves changes that confer an immediate survival advantage. Irreducibly complex systems, by definition, do not provide a gradual, stepwise function. They only work when all components are present and correctly arranged. For instance, in the bacterial flagellum, even if mutations produced one part of the motor, such as the rotor, it would have no use without the propeller, the stator, and other parts. A bacterium with only a partial flagellum would derive no survival advantage from it. Therefore, there is no reason for natural selection to preserve a partially constructed flagellum. The idea that random chance could generate such interdependent systems without direction or design is mathematically and biologically improbable. Incremental functionalism and its limits. One counter-argument to irreducible complexity is the notion of exaptation, where systems that originally served one function are co-opted over time to perform a new function. Evolutionary theorists suggest that components of an irreducibly complex system might have existed previously for different purposes and were gradually reassembled into a new system. For example, parts of the bacterial flagellum might have evolved for other, unrelated tasks and later came together to form the motorized structure we observe today. While this hypothesis provides an alternative framework, it suffers from significant gaps. The components of irreducibly complex systems are often so specialized that their previous, simpler, functions do not account for their current complexity. In cases like blood clotting or the immune system, the interdependence of parts is so tight that functional intermediates are not viable. Additionally, no direct evidence has been presented for the stepwise, functional shifts necessary for exaptation to account for irreducible complexity in highly interdependent biological systems. Information and design. Another critical issue that random chance cannot solve is the origin of information in biological systems. DNA, RNA, and proteins are information-bearing molecules that direct the construction of functional biological systems. The information contained in these molecules is not merely a random arrangement of nucleotides or amino acids but a highly specific sequence that enables biological function. To illustrate the difference between randomness and specified complexity, imagine attempting to produce the text of this article by randomly typing on a keyboard. The probability of generating a coherent sentence, let alone an entire article, by chance is absurdly low. Similarly, the sequences found in DNA are not random but are instead highly ordered and functional, carrying instructions for building irreducibly complex systems. Random processes, such as mutation, do not generate new information. Instead, mutations typically degrade or rearrange existing information, often leading to loss of function rather than the creation of new, complex systems. By contrast, the information necessary for irreducibly complex systems to function is best explained by an intelligent source, as random processes cannot account for the rise of functionally specified information. The case for intelligent design. Irreducibly complex systems bear the hallmarks of intelligent design. These systems demonstrate intricate interdependence, functional specificity, and information-rich structures that cannot arise through unguided processes. In the same way that a finely tuned watch implies the existence of a watchmaker, irreducibly complex biological systems point to an intelligent designer. The limits of random chance and natural selection in generating such systems suggest that the best explanation lies outside of undirected naturalism. The presence of functional, irreducibly complex systems in biology aligns well with the notion that life was purposefully designed with specific goals in mind. Conclusion. The notion that functional irreducible complexity could arise by random chance is not tenable given the overwhelming improbability of such events occurring through undirected processes. The interdependence of biological components, the specificity of functional information, and the limits of mutation and selection make a strong case against naturalistic explanations for the origin of these systems. Instead, irreducible complexity points to the action of an intelligent cause, providing a powerful argument for the presence of design in the natural world. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.